cannot function for a certain period of time. Okay, but if the system is repairable, then the average uptime would be increased. Okay, so the system is now available. Let's see the next one. This example that assuming that there is a system consisting of 10 components connected in series like as we see here. Okay, if we know the reliability of each component, let's say that they are identical. Each component has reliability equal to 0.99. For the system to function, it requires all the components to function. In other words, if there is just one component breaks down, then this system will fail. So that the system reliability would be just the product of all the component reliability. Okay, that is 0.99 power 10. So we see that the system reliability is equal to 0.9. We see that x less than component reliability. That makes sense because the system depends on each individual component, right? If one is not good, then it directly affects to the system reliability. Okay, so the formula, don't worry about the formula. We are going to discuss about that, how we get to this formula and the detailed meaning of that. This is just to give you just the overview of what we can find out and what's the relationship of components toward the system reliability. Okay. Another parameter is mean time between failure. This also can be identified that there exists a formula related that tells us the relationship of reliability and mean time between failure. Okay, once we know one parameter, we can find out the other one. Okay, for this example, mean time between failure is 75.9 hours. Okay. Another issue that we would be very familiar with is about quality. Okay, what's the similarity or the difference between the two, reliability and quality? Can be defined qualitatively. So that means it's very difficult to define actually qualitatively, right? On the other hand, the quantitatively, okay, like we can come up with some numbers, and that number would be about the quantity, right? So the issue here is about the qualitatively and the quantity. Quality and the quantity are different. Okay, so quality of a product would be involved with several issues like the customer satisfaction, that's one of them, or it could be like users' requirements. So it could be anything that we think that it's about quality, or it could be problem specific, right? However, for reliability, we see that we use probability to define. So it's a quantity that we could just capture explicitly. The reliability is concerned with how long the product continues to function. Once it is operating, okay, how long can it last? There's some relationship for reliability and quality, like that once a product has poor quality, it means that usually that product would have poor reliability as well. Or reliability can be viewed as quality in the time domain. Okay, quality, how long the product can last. Okay, so that the user or the customer won't have to spend extra money to purchase the new product to replace the failed one. In order to have good quality for a system, there should be like quality assurance program that have to be analyzed. Okay, so now we see a lot of issues related to reliability, which are quality, availability, maintainability. Okay, so now let's see some examples, some applications. Okay, what kind of problems or information that we can analyze toward the knowledge of reliability. Let's see the first example here. That given the information that there is a company that they make small motors for use in household appliance. The motor can be used for maybe, let's say, refrigerator, could be for something that you can think of, okay, in a household appliance. This example is in the text, so you would like to take a look at that as well. For the table, let's see the information in table 1.2. Okay, here it is. Okay, that once this company they make the small motors, so they like to see how their motors are behaving, like how often they fail. Okay, we see that for the first, this number here, we see a lot of columns. The first 100 units of the motor, they test, the number of tests is shown here as 2,540 hours. They are using accelerated testing so that they can see the results. So this is not in a normal operating condition, but the extreme condition, so that they test how the motor are behaving, and the result turn out that 12 motors, that is one failed. Okay, and for the next, once they produce more motors, we see that at this time the failure rate is 0. But once they